Smart telescopes look like magic. You set one down, you tap your phone, and suddenly you're looking at faraway galaxies and nebulas. But is it really magic? Or is it just good engineering? That's the question I want to answer today. And to do it, we will need to look inside one. Luckily, I happen to have a transparent smart telescope here, the Vespera X-Edition by Vaonis, which lets us have X-ray vision of the workings of a smart telescope so we can see what goes on under the hood. It exposes the motors, the computer, the battery, all the components that normally stay hidden. And because of this peculiarity, it becomes easier to understand what's actually happening inside. That also raises the question, why would a company produce a telescope with a transparent shell? Vaonis has this tradition of releasing limited editions from time to time, each with a distinctive aesthetic and produced in small numbers. Sometimes the design is inspired by art, like the Stellina art version of the Stellina. Other times it celebrates space exploration, like the Blue Frontier edition of the Vespera, and in this case it highlights the engineering itself with a clear shell that reveals the inner workings. These editions don't usually add new functions compared to the standard models. They're collector's items more comparable to a limited edition watch than a technical upgrade. So let's start. My name is Lucia and you're watching the Space Koala. Over the past 5 years, smart telescopes have no doubt taken the world by storm, with more and more options available in different price ranges and sizes from different brands. But one of the very first companies to enter this market was the French company Vaonis, when they first released their original Stellina. Back then, a lot of traditional astronomers were skeptical, but over time, smart telescopes have earned their place in astronomy clubs, outreach events, and even astrophotography clubs. What's going on inside these devices that lets them take pictures of the night sky automatically? That is what we're going to break down step by step. So let's imagine we want to take a picture of something in the night sky. What's the very first thing we need? We need to be able to collect as much light as possible from the object we want to picture. To make this more difficult, most things in the night sky are incredibly faint. You can barely see them with the naked eye, if at all. That is why we need some kind of a light bucket. In astronomy, that bucket is the telescope. The bigger the front lens, the more light it can collect. Just like putting a larger bucket outside in the rain, you'll catch more drops in the same amount of time. Let's take a look at this component inside the shell. The black tube you see here is the actual optical telescope. It has an aperture of 50 millimeters and uses 4 glass elements which help keep stars looking cleaner across the whole frame. At the front, there's a built-in dew heater to keep the lens clear on humid nights. And as the tube itself is black, no stray light can leak in through the transparent shell and interfere with the optics. But to actually take a picture, we still need a camera. In traditional astrophotography, you'd attach a DSLR or a dedicated astronomy camera at the prime focus of the telescope. With a smart telescope, the camera is already built in. In the Vespera X-Edition, that camera is based on the Sony IMX585 sensor. If you're not familiar with it, that is a 4K sensor that's become very popular in astrophotography because of its sensitivity and small pixels. And here it is paired with a passive cooling system meant to reduce thermal noise. And if you look closely through the transparent shell, you can just make out the camera sitting at the end of the optical tube with the cables running out from it to connect with the rest of the system. That's the point where all the collected light is recorded and turned into data. But just catching the light isn't enough. We need that light to land precisely on the sensor, and this is where focus comes in. If you've ever taken a photo of a person or an object and missed the focus, you know the result. It looks soft and blurry. Now imagine trying to photograph stars, which are literally just points of light. Even the tiniest error in focus makes them swell up and look bloated. In traditional telescopes, focus is handled with a manual focuser, sometimes upgraded with a motor so that it can be controlled by software, which moves the camera, or an optical element until the image is sharp. Most smart telescopes embed both the focuser and a tiny motor that enable automatic focusing. And if you look closely through the transparent shell of the Vespera X, you can see that tiny motor responsible for keeping the stars in perfect focus. It works a lot like the way your camera autofocuses on a face, but designed specifically for pinpoint stars, and it keeps refocusing through the night as temperatures change. Now, because these objects are so faint, we can't just take one quick picture and be done. We need to keep the telescope pointed at our target and gather light for a long time. This is where Earth decides to make life complicated. Our planet is constantly rotating, which makes the stars appear to move across the sky. And if we don't compensate for that, all the stars in our photos will quickly smear into streaks. Traditionally, astronomers solve this with something called equatorial tracking. You carefully align the telescope so that one of its axes matches the axis of Earth's rotation. If you get it just right, the mount can move along a single axis and follow the stars perfectly. It's clever, but it takes practice and precision to get it right. That's why when smart telescopes were first introduced, they took a different approach. The idea was to lower the barrier to exploring the night sky to make it possible without needing too much prior knowledge or setup complexity. Instead of relying on one precisely aligned axis, they use two motors, one moving horizontally and another one moving vertically, both of them controlled by software to keep the target centered. Through the transparent shell, you can kind of see these motors at work, driving the mount with brass gears. The trade-off is that while the system is definitely easier to use, it introduces something called field rotation. The object stays centered, but the entire frame slowly rotates over time. Because of that, smart telescopes can't take super long exposures. If they tried, you'd see the stars start to smear and rotate in the frame. So instead, the telescope just takes lots of very short exposures, just a few seconds each. That's why some smart telescopes now include the option of polar alignment, which allows for longer exposures, typically in the range of 30 to 60 seconds, compared to the 10 to 20 on the Vespera. One short exposure on its own doesn't look like much. It is noisy, the details are faint, and you might barely recognize the object. But if you take hundreds or even thousands of them and combine them, something amazing happens. The noise averages out and the faint structures begin to emerge. In a traditional setup, this means hours and hours of post-processing. You'd start by calibrating your images, which removes optical and digital artifacts. Then you'd register them, which just means lining them up so that the stars overlap exactly. And finally, you'd stack them, averaging all of those exposures together. That's the step that reduces noise and reveals the faint details. But even after stacking, you're not finished. The image may look dull and flat. To make it shine, you do things like color calibration, stretching the curves, adjusting contrast, and removing gradients from light pollution. Only after all of that does the real beauty of the nebula or galaxy come out. Smart telescopes automate most of these steps. Some models even use calibration frames like darks or flats, but the one we're looking at here doesn't. It skips that part entirely while still taking care of the rest: alignment, stacking, live image building, color balance, and gradient correction. As the night goes on, you can actually watch the picture slowly form on your screen, detail by detail. Controlling this amount of hardware, ensuring that they work together, and then also doing processing automatically means you need a computer to command it all. We can see the logic board located in the inside of the telescope that is responsible for turning incoming starlight into beautiful astrophotos. All of this hard work requires energy, which is provided by the battery, which provides approximately 4 hours of operation time, extendable by using an external power source. Now that we have gone through the basics of how a smart telescope works, let's focus on this specific one. Vaonis sent me this unit for testing, and I've been using it for a few nights, so I have had the chance to experience what makes it different and what you can actually expect when you use it out under the stars. Let's set the record straight. From a functional point of view, this edition doesn't differ in any way from the standard Vespera II. As we mentioned earlier, it is a collector's edition, something that may appeal to people who are already interested in the Vespera II, but want the exclusivity of a limited model. What does set it apart is the included accessories. The unit comes with a new lightweight carbon tripod and its protective sleeve. It is convenient and portable, though not as sturdy as the taller tripods Vaonis had offered in the past. It also includes a hard case, which is a real improvement over the usual fabric sleeve that ships with the standard Vesperas. And finally, it comes with a hygrometer sensor already pre-installed, working in tandem with the built-in dew heater. Using this telescope is straightforward. Everything runs through the Singularity app, which offers a clean, beginner-friendly interface. There are only a few options, so it gets you shooting quickly, but it also means you don't get the same level of customization and control that some other smart telescopes provide. I worked with the plan mode, which lines up several targets for the telescope to capture one after the other. This isn't unique. Practically all smart telescopes now have a planning feature, and I've already made a separate video comparing how they work, which I'll link below. The idea is simple. You set up a list of objects, start the plan, and then the telescope runs through them one after the other while you do something else, even sleep. If you want to change the native field of view, you can even use the covalence feature. It lets you capture a larger area than what the telescope natively offers. The telescope offsets its position slightly between exposures, spiraling across the target until it covers the entire desired area. All of those smaller frames are then stitched together into one wide image. This technology works so well that variations of it have since been implemented in essentially all smart telescopes. And what if one night of imaging just isn't enough to finish your observation? Normally, you'd have to start over the next night and then try to process everything together yourself. But Vaonis also introduced something they call perseverance, which lets you continue where you left off. So the next night, the telescope simply keeps adding new exposures to the stack you already started before. At the moment, this approach is still unique to Vaonis. In terms of optical performance, I was pleasantly surprised at the quality. I didn't run into the issues I had previously encountered with the Vespera Pro that I had reported on the channel, which turned out was related to a faulty unit I received. The stars are reasonably consistent across the frame with only minor distortions near the edges, which I believe outperforms some of the other smart scopes on the market, especially considering that the Vespera does this with a larger sensor too. Looking at the results straight out of the app, the images looked okay at first, but then I did notice some artifacts around the corners. This seems to come from the automatic background correction they do, which sometimes overdoes it. The good thing is that those artifacts are not present in the stacked TIFFs, so if you download those and process them yourself, the problem disappears. So the data itself is fine, but the automatic processing can produce unnatural looking results. I have passed this feedback on to the company, and I hope they'll take it into account for future software updates, but so far I haven't received any assurance that this will change. The special edition also carries over some of the hiccups of the regular Vespera II when it comes to data storage. The internal memory is only 25 gigabytes, and the frames are rather large. So if you try to save every individual raw file, you'll fill the storage very quickly, sometimes even before finishing a single night. On top of that, transferring files can only happen over Wi-Fi, which is slow and makes working with hundreds or thousands of RAWs even less practical. For these reasons, it really makes more sense to stick with the stacked TIFFs. They give you good quality data to process later without overwhelming the limited storage or forcing you to wait endlessly for transfers, though of course you lose the full flexibility that saving every single image would offer. So what is my take on the Vespera X-Edition, or really on the Vespera II in general? The optics are great. The stacking works as expected, and the design makes it very simple to set up and use. But the automatic processing, the background correction, is heavy-handed and often creates artifacts, and without flat field calibration, the results don't always look natural. The raw stacked files, on the other hand, are nice. If you want the best results, you'll need to process them yourself. With a price tag of $2,500, the X-Edition sits above that of the standard model. The transparent shell is beautiful, striking, but it has a real drawback. The light inside the case is bright and cannot be turned off. I would strongly discourage bringing it to a star party or any dark sky event because that glow will disturb others. And if you're not especially drawn to the transparent case, you might consider the regular Vespera II instead, since it's the same instrument at a lower price. If you're in the market for a 50 to 50mm smart telescope and you want the best sensor option as well as the widest field of view, the Vespera II could be your best bet, keeping in mind the trade-offs such as no equatorial mode now or planned for the future and no image calibration. I will link the telescope specifications below if you want to check them out for yourself, and I am curious, what do we think about this telescope? Is the transparent case something you genuinely want, or does it feel more like a gimmick? Let me know in the comments. I'd like to hear other people's opinions. Thank you very much for watching, and as always, I wish you clear skies.